In this research paper titled, TIFIN India at SemEval-2025, Harnessing Translation to Overcome Multilingual IR Challenges in Fact-Checked Claim Retrieval, the authors Prasanna Devadiga, Arya Sunish, Pawan Kumar Rajput, Bharatdeep Hazarika, and Aditya U. Balaga from TIFIN India and IIT Kottayam present their approach to tackling misinformation through advanced information retrieval techniques. The abstract outlines their method for retrieving previously fact-checked claims in both monolingual and crosslingual settings. This is crucial because misinformation spreads globally, and fact-checkers need tools to quickly identify verified claims across languages. Their system uses a two-stage strategy. First, a reliable baseline retrieval system based on a fine-tuned embedding model, and second, an LLM-based reranker to refine the results. A key innovation is using large language models for translation to handle the challenges of multilingual information retrieval. They also emphasize making their pipeline replicable on consumer-grade GPUs, which means it's accessible without high-end hardware. Their final system achieved a success at 10 score of about 0.94 for monolingual tests and 0.81 for crosslingual tests. All their code and trained models are publicly available on GitHub. Moving to the introduction, the paper highlights how misinformation is one of the top global threats, as noted by the World Economic Forum. It spreads rapidly through social media, eroding trust in institutions and fueling divisions, especially during political events. This work participates in SemEval-2025 Shared Task 7, which involves building systems to retrieve fact-checked claims from the multi-claim dataset. The goal is to match social media posts in various languages to existing fact-checks. Success is measured by the success at 10 metric, meaning if a relevant fact-checked claim appears in the top 10 results, the system is considered effective. The task overview explains that SemEval-2025 Task 7, as described by Pung and colleagues, deals with finding fact-checked claims across languages, which is challenging when claims and fact-checks are in different languages. It's divided into monolingual and crosslingual tracks. The dataset comes from a subset of multi-claim, created by Pikulik and others, and includes social media posts, text from images via OCR, and translations. This helps fact-checkers worldwide by automating the process, as manually searching across languages is impractical. In the related work section, the paper reviews the evolution of fake news detection. Early studies, like those by Castillo and colleagues in 2011 and Xu and others in 2017, focused on assessing credibility using textual, user, and network features on social media. More recent efforts, such as those by Kumar and Shah in 2018 and Perez Rosas and team in 2018, delved into linguistic patterns and external taxonomies for better detection. The paper then discusses fact verification systems. It references the pioneering Fever dataset and framework by Thorne and colleagues in 2018, which became a benchmark. Building on that, Augenstein and others in 2019 developed models that transfer knowledge across domains. Neural approaches, like the Neural Evidence Retriever Aggregator by Ni and team in 2018, integrate evidence retrieval with verification. Transformer-based models, such as the Knowledge Graph Attention Network by Wadden and colleagues in 2020, use structured knowledge for improved reasoning. Finally, Lewis and others in 2020 introduced Retrieval Augmented Generation Models, or RAG, which combine neural retrievers with language models to provide verifiable explanations. Shifting to the methodology, the paper describes their approach starting with a baseline embedding-based retrieval system enhanced with data augmentation. This is essentially an information retrieval problem where they need to find relevant fact-checks for social media posts in multiple languages. They begin with a fine-tuned embedding model, which likely involves training on embeddings that represent text in a way that captures semantic meaning across languages. The paper mentions a figure illustrating the data preparation and model fine-tuning pipeline, though we don't have the visual here. This pipeline probably involves processing the dataset, augmenting it with translations or other data to handle multilingual aspects, and then fine-tuning the model on this prepared data. Their key contribution is leveraging LLM-based translation to overcome multilingual challenges. Large language models, like those from GPT or similar families, are used not just for reranking but also for translating text between languages. This allows the system to bridge language gaps, making it easier to retrieve relevant claims even if the query and the fact check are in different languages. The two-stage strategy works like this. In the first stage, the embedding model retrieves a broad set of potential matches based on similarity. Then, in the second stage, the LLM-based reranker evaluates these matches more precisely, possibly using contextual understanding and translation to ensure accuracy. Importantly, they designed the system to run on consumer GPUs, which means it's optimized for efficiency and accessibility. This is vital for real-world applications where not everyone has access to powerful computing resources. Overall, this research demonstrates a practical and innovative solution to a pressing global issue, showing how combining traditional IR techniques with modern LLMs can enhance fact-checking efforts in a multilingual world.